Okay, all right. So now we are trying to think in terms of the chain rule. So how do we build something that where we have a function inside of another function? This is how we have to think. So we want to write things in these terms and then find the derivatives of those. So let's look at a. So a is 1 over x plus 1. So generally, look around what x is doing. Your interior functions are going to be like one set of PEMDAS away from just the closest x can be. So in this case, we see that x, there's only one thing really happening on its level, which is you're adding 1. So that's your interior function, is x plus 1. Now this whole x plus 1, this is a function, is being taken to the negative first power. So that is the second function. So this is inner, and this is outer. Think of it as the order that you do it. Outer is the thing you do last. Inner is the thing that you do first. You know, if you were to plug in a number to x, the first thing you would do is add to it. And then you would take it to the negative 1. That'll tell you the inner and outer functions. So if we took the derivative of this up here of y, what you would get based on our general power rule is going to be negative 1 times x plus 1 to the negative 1 minus 1 times the derivative of x plus 1, which if you solve this out, you would get negative x plus 1 to the negative 2. The derivative of x plus 1 is just 1. So this is negative x plus 1 to the negative 2. So b, we've got the sine of 2x. Well, for this, we have an interior function of 2x. That's the thing that's, if you plugged a number into x, you would first multiply it by 2, and then you would take the sine of it. So that's your inner and your outer. So if we did y prime, we start off we do the outer function, right? The outer function, if we do sine, tells us that that is derivative is cosine. The 2x remains inside. We then multiply by the derivative of 2x, because we have to do that. This is going to end up being 2 times the cosine of 2x. Now if we look down here, so c gives us the square root of 3x squared minus x plus 1. Well, what's the inner function here? That's going to be this entire list here. So when we're adding and subtracting around x, that is the whole inner function. We are taking the square root of this whole thing. So that's the inner and outer. So the way that we want to think about this is 3x squared minus x plus 1 to the 1/2 power. All right, so that is, now we can do our general power rule, which says that if we have y prime, we're going to get 1/2, because we bring that down, times the 3x squared minus x plus 1 stays there. We do the negative 1/2, or excuse me, 1/2 minus 1. But then we have to multiply by the derivative of 3x squared minus x plus 1. We have to multiply by the derivative of it. So if we end up simplifying, we get 1/2 times 3x squared minus x plus 1 to the negative 1/2. And then the derivative of 3x squared minus x plus 1 is going to be 6x minus 1. So we can go forward and simplify a little bit more, but I've run out of room. But these are examples of how we not only identify what a inner and outer function is, but also what you have to do to go about taking the derivative of it. So let's look at a couple more examples. So it says find dy dx, which is the same thing as a derivative of y equals x squared plus 1 cubed. So we're going to go about doing the general power rule. So y prime is going to be, we're going to bring the 3 down. We multiply by x squared plus 1 to the 3 minus 1. We then have to multiply by the derivative of the inner function, which is x squared plus 1, by its derivative. So we take our time, we get 3, the x squared plus 1 squared. The derivative of this is just going to be 2x. So we should get, when we combine terms, 6x times x squared plus 1 squared. So this is a perfectly simplified answer, and we're good there. Main thing that you want to keep in mind is that anytime you use these rules, you just got to make sure that you're accounting for the innermost function. And as we move on, so applying the derivative, so we've got f of x equals 3x minus 2x squared cubed. So just like we did, we're going to get f prime of x. We bring the 3 down. We multiply by the inner function as it was. We take 1 away from the exponent, and then we multiply by the derivative of the inside. So simplifying, 3 times 3x minus 2x squared. And this derivative is going to be 3 minus 4x. So to simplify, what I would do is I would combine these two things together. I wouldn't worry about the rest. So if I did that, you would get 9 minus 12x times 3x minus 2x squared. And you don't even really necessarily have to do that. This could be okay. Okay, so another question. So we need to use this. So this says, find all points on the graph of f of x equals the cube root of x squared minus 1 squared, for which f prime of x equals 0, and those for which f prime of x does not exist. So the first step is always take the derivative. Always. So f of x we had as, I'm going to rewrite this as x squared minus 1 to the 2/3, because that's the same thing, right? The x squared minus 1 is squared, taking the cube root of it, so that's why we end up looking like that. So first off, we find our derivative, and that is going to be 2/3 times x squared minus 1 to the 2/3 minus 1. Then we multiply that by the derivative of x squared minus 1. So this is going to be 2/3 times x squared minus 1 to the negative 1/3 times x squared minus 1, or to the derivative of that, which is going to be 2x. So it's asking for when it's 0 and when it doesn't exist. So I tend to think that it's easiest to do this if we have it set up in a nice clean way. So I'm going to set this function up kind of formally. So what's in the numerator and what's in the denominator? Well, 2 is a numerator, 2x is a numerator, the rest is in the denominator. And I know this because a negative exponent is a denominator and a 3 is there. So these are the things that go together. So 2 times 2x gives me 4x. And the bottom is going to be 3 times the cube root of x squared minus 1. All right, so when does f prime of x equals 0? So f prime of x equals 0. That's only when 4x equals 0. And f prime of x does not exist when 3 times the cube root of x squared minus 1 equals 0. So let's find the places that this happens. Well, this is when x is 0. This one over here, you can do some solving out, but you should find this is when x equals positive or negative 1. So these are the 3 places that you're going to have issues with in your problem, where f prime of x doesn't exist or f prime of x equals 0. Lastly, we're going to differentiate something with the quotients. So it's all about how we have to write this. So g of t is going to be negative 7 over 2t minus 3 squared. Well, I'm going to rewrite this as negative 7 times 2t minus 3 to the negative 2. So when we go through and find the derivative, the negative 2 comes down, but I also multiply by negative 7, and I still have my 2t minus 3 to the negative 2 minus 1. But then I still have to multiply by the derivative of the inside function. So lots of stuff going on. And so I'm going to keep moving. So negative 2 times negative 7 is going to give me 14. I get 2t minus 3 to the negative 3. And then finally the derivative of all this is just 2. So overall, you should end up with this as your final answer.